NENOMATICA, where mathematics meets YouTube excellence. In this video, we simplify a symmetric rational expression step by step using smart common denominators and factoring. Let's get started. Step 1. Write the original expression. Pause and think what simplification pattern might appear. Step 2. Rewrite the second and third terms using sign flips so all factor patterns match. We use b minus a equals negative of a minus b and c minus a equals negative of a minus c. Step 3. Combine over the common denominator. A, bc times a minus b times a minus c times b minus c. Step 4. Expand the numerator carefully. Step 5. Group the terms to prepare factoring by pairs. Step 6. Factor each group. Notice common factors appear. Step 7. Factor the bracket further. Use c squared minus a squared equals left parenthesis c minus a right parenthesis times left parenthesis. Notice common factors appear. Step 7. Factor the bracket further. Use c squared minus a squared equals left parenthesis c minus a right parenthesis times left parenthesis c plus a right parenthesis. Then factor out c minus a. Step 8. Substitute c minus a equals negative of a minus c. Then cancel the a minus c factor with the denominator. Step 9. Group the terms inside the bracket for a common factor. Step 10. Factor each group to reveal b minus a as a common factor. Step 11. Factor out b minus a. Step 12. Cancel b minus c. And use b minus a equals negative of a minus b. The two negatives multiply to a positive, leaving 1 over abc. Summary. We aligned signs, combined over a common denominator, grouped the numerator, factored strategically to reveal matching factors, and canceled to reach the elegant result, 1 over abc, minus a equals negative of a minus b. The two negatives multiply to a positive, leaving 1 over abc. Summary. We aligned signs, combined over a common denominator, grouped the numerator, factored strategically to reveal matching factors, and canceled to reach the elegant result, 1 over abc. Grouped the numerator, factored strategically to reveal matching factors, and canceled to reach the elegant result, 1 over abc. Here is the original expression. We will call it capital S. Our plan is to factor each numerator and denominator, look for common factors, and then combine the simplified fractions. Step 1. Factor each denominator. First, we note that left denominator is a difference of squares. Left bracket x squared plus 1, quantity squared, minus x squared. That equals the product of x squared minus x plus 1, and x squared plus x plus 1. For the middle denominator, x squared times x plus 1 squared minus 1 can be reorganized as the quantity x squared plus x squared, minus 1, that is x squared plus x all squared minus 1, which again is a difference of squares. It factors into x squared plus x minus 1 times x squared plus x plus 1. For the right denominator, x squared minus the quantity x squared plus 1 squared equals negative of the left denominator. So it is negative 1 times x squared minus x plus 1 times x squared plus x plus 1. Step 2. Factor the numerators. Notice that x to the fourth minus the quantity x minus 1 squared factors nicely into two quadratic factors. That is x squared minus x plus 1 times x squared plus x minus 1. Also, x squared times x minus 1 squared, minus 1 factors into x squared minus x plus 1 times x squared minus x minus 1. Step 3. Rewrite each fraction using these factorizations and cancel common factors. For the first fraction, both numerator and denominator contain x squared minus x plus 1, so it simplifies to the quantity x squared plus x minus 1 over the quantity x squared plus x plus 1. For the second fraction, numerator and denominator both contain x squared plus x minus 1. This simplifies to the quantity x squared minus x plus 1 over the quantity x squared plus x plus 1. For the third fraction, there is an overall negative sign in the denominator. After cancellation, that becomes minus the quantity x squared minus x minus 1 over the quantity x squared plus x plus 1. Step 4. Put these simplified results back into the original sum. All three fractions now share the same denominator, x squared plus x plus 1. We just add their numerators. Combine the numerators over the common denominator. The numerator becomes left parentheses x squared plus x minus 1, right parentheses plus left parentheses x squared minus x plus 1, right parentheses minus left parentheses x squared minus x minus 1, right parentheses. Now simplify the numerator carefully. The terms combine to x squared plus x plus 1. That gives the numerator equal to the denominator. Therefore, the entire expression simplifies to 1. In this lesson, we will simplify a rational algebraic expression step by step using sign flips, common denominators, expansion, factoring, and cancellation. Watch carefully how each algebra move is visualized on screen. Step 1. We rewrite the pieces that have reverse signs in their denominators. Use the identities b over b minus a equals negative b over a minus b, and b squared minus a squared equals negative of a squared minus b squared. This will let us combine terms with a common denominator cleanly. Step 2. Focus on the first big bracket. We combine the three terms into a single fraction with denominator a squared minus b squared. Step 3. Now expand and simplify that numerator. A times a minus b plus b times a plus b minus 2ab. Notice that negative ab and positive ab cancel. We are left with a squared plus b squared minus 2ab, which factors into the square of a b squared minus 2ab, which factors into the square of a minus b. Step 4. Since a squared minus b squared factors as a minus b times a plus b, the square of a minus b over a squared minus b squared becomes a minus b over a minus b times a plus b. Canceling a minus b leaves a over a plus b for the first part. Step 5. Now simplify the second big bracket. Write negative b over a minus b as negative b times a plus b over a squared minus b squared. Then add to a b over a squared minus b squared. Combine numerators. Step 6. Now the denominators match, so we add the numerators. A plus b over a plus b equals 1. We carefully turned opposite sign denominators into a common form, combined terms, expanded and factored, then canceled to reveal a clean result. The entire expression simplifies to 1. Here is the example we will simplify. We'll also keep in mind the domain conditions x and y are non-zero, and x is not equal to y. Step 1. We rewrite each bracket using common denominators and a key identity. Recall the difference of squares x squared minus y squared equals x minus y times x plus y. Now apply it as we combine the inner sums into single fractions. Step 2. Use the reciprocal rule. The inverse of a fraction, a over b, is b over a. Apply it to the first inverse term. Step 3. Apply the reciprocal rule again to the remaining inverse. Step 4. Now factor x squared minus y squared as x minus y times x plus y, and prepare to cancel common factors. Step 5. Cancel 1x minus y and 1x plus y from numerator and denominator. Everything cancels cleanly, leaving 1. This simplification x minus y and 1x plus y from numerator and denominator. Everything cancels cleanly, leaving 1. This simplification holds for x not equal to 0, y not equal to 0, and x not equal to y, so we never divide by 0 during the process. Recap. We combine fractions inside each bracket, use the reciprocal rule twice, factor the difference of squares, and then cancel common factors. The entire expression simplifies to 1. Here is the expression. We will work it carefully. Step 1. Factor all quadratics. We factor the numerators and denominators. A squared minus 6, a plus 5 equals left parenthesis, a minus 1 right parenthesis times left parenthesis, a minus 5 right parenthesis. A squared minus 7, a plus 10 equals left parenthesis, a minus 2 right parenthesis times left parenthesis, a minus 5 right parenthesis. A squared minus 6, a plus 8 equals left parenthesis, a minus 2 right parenthesis times left parenthesis, a minus 4 right parenthesis. A squared minus 5, a plus 4 equals left parenthesis, a minus 1 right parenthesis times left parenthesis, a minus 4 right parenthesis. a squared minus 3 a plus 2 equals left parenthesis a minus 1 right parenthesis times left parenthesis a minus 2 right parenthesis. Now, we rewrite the entire expression using these factorizations. Step 2. Division becomes multiplication by the reciprocal. We multiply by left parenthesis a minus 1 right parenthesis times left parenthesis a minus 2 right parenthesis. Step 3. Cancel the common factors in each fraction. In the first fraction, the factor a minus 5 cancels. In the second fraction, the factor a minus 4 cancels. That leaves a minus 1 over a minus 2 minus a minus 2 over a minus 1. All times left parenthesis a minus 1 right parenthesis times left parenthesis a minus 2 right parenthesis. Step 4. Combine the two fractions into one. Subtracting with common denominator gives a minus 1 over a minus 2 minus a minus 2 over a minus 1 equals a minus 1 squared minus a minus 2 squared over left parenthesis a minus 1 right parenthesis times left parenthesis a minus 2 right parenthesis. Now multiply by left parenthesis a minus 1 right parenthesis times left parenthesis a minus 2 right parenthesis, and it cancels the denominator. We are left with a minus 1 squared minus a minus 2 squared. Step 5. Expand and simplify. A minus 1 squared equals a squared minus 2 a plus 1. A minus 2 squared equals a squared minus 4 a plus 4. Subtracting them gives 2 a minus 3. Therefore, the simplified result is 2 a minus 3. Important domain note. From the original denominators, a cannot be 1, 2, 4, or 5. So the final answer is valid for all real and not equal to 1, 2, 4, or 5. Recap. We factored, turned division into multiplication by the reciprocal, canceled common factors, combined the difference, and simplified to get the final result. Here is the problem. We will simplify the expression. Notice the structure. Each parenthesis contains a fraction plus or minus a variable, and we subtract two products. Strategy. First, rewrite each parenthesis as a single fraction by putting terms over a common denominator inside the parenthesis. Then multiply. Combine the results over a common denominator, expand and simplify, factor, and finally cancel a common factor to get the result. Step 1. Combine the terms inside each parenthesis. For the left product, the first parenthesis becomes b over a plus b plus, which equals b plus a times quantity a plus b, all over a plus b. The second parenthesis becomes a over a minus b, which equals a minus b times quantity a minus b, all over a minus b. For the right product, the first parenthesis becomes a over a plus b, which equals a plus b times quantity a plus b, all over a plus b. The second parenthesis becomes b over a minus a, which equals b minus a times quantity a minus b, all over a minus b. Step 2. Multiply the simplified fractions and combine the two products over the same denominator. Both products share the denominator a plus b times a minus b, so we can write the whole expression as one fraction with that denominator, and the numerator is the first product numerator minus the second product numerator. Step 3. Expand the numerator carefully and collect like terms. Many terms cancel. After simplification, the entire numerator reduces to negative 2ab squared plus 2a cubed. Step 4. Recognize that a squared minus b squared equals a plus b times a minus b. Therefore, the numerator and denominator share a common factor a plus b times a minus b, which cancels. Under our assumption that a is not equal to plus or minus b, the cancellation is valid. Final result. The simplified value of the original expression is 2a with the condition that a is not equal to b and a is not equal to negative b. In this lesson, we will simplify a rational expression by factoring and combining fractions over a common denominator. We'll go step by step, keeping the algebra clear and visual. First, here is the original expression we want to simplify. Strategy. We will factor the denominators and look out for sign changes. Notice the second denominator is y to the sixth minus x to the sixth, which is the negative of x to the sixth minus y to the sixth. That sign flip will turn the plus into a minus for that fraction. Next, factor x to the sixth minus y to the sixth, as left parenthesis x cubed minus y cubed right parenthesis times left parenthesis x cubed plus y cubed right parenthesis. We'll substitute that into the denominator. To combine the two fractions, we need a common denominator. The common denominator is left parenthesis x cubed minus y cubed right parenthesis times left parenthesis x cubed plus y cubed right parenthesis. Multiply the first fraction by left parenthesis x cubed plus y cubed right parenthesis over left parenthesis x cubed plus y cubed right parenthesis. Now focus on the numerator. Distribute y squared across the parentheses. Y squared times x cubed plus y squared times y cubed, then subtract x cubed y squared. The y squared x cubed and the minus x cubed y squared cancel perfectly, leaving just y to the fifth in the numerator. Therefore, the entire fraction simplifies to y to the fifth over left parenthesis x cubed minus y cubed right parenthesis times left parenthesis x cubed plus y cubed right parenthesis. That is. Here's our problem. We will recognize perfect squares, combine into a single fraction, factor using difference of squares, and then simplify by canceling common factors. Step 1. Recognize that 1 minus 2x plus x squared is a perfect square. It equals left parenthesis 1 minus x right parenthesis squared. Also, 1 plus 2x plus x squared is left parenthesis 1 plus x right parenthesis squared. Using these, we rewrite the original expression. Step 2. To add these, we write the first term over the common denominator left parenthesis 1 plus x right parenthesis squared. Then combine the numerators into a single fraction. Step 3. Use identities. Left parenthesis 1 minus x right parenthesis squared times left parenthesis 1 plus x right parenthesis squared equals left parenthesis 1 minus x squared right parenthesis squared. And 1 minus x to the fourth equals left parenthesis 1 minus x squared right parenthesis times left parenthesis 1 plus x squared right parenthesis. Substitute these into the numerator. Now factor out the common factor left parenthesis 1 minus x squared right parenthesis. Step 4. The bracket simplifies to 2. So the whole fraction becomes 2 times left parenthesis 1 minus x squared right parenthesis over left parenthesis 1 plus x right parenthesis squared. Step 5. Factor 1 minus x squared as left parenthesis 1 minus x right parenthesis times left parenthesis 1 plus x right parenthesis. Then cancel a common left parenthesis 1 plus x right parenthesis factor from numerator and denominator. Remember the domain restriction, x cannot equal -1. Final answer, 2 times left parenthesis 1 minus x right parenthesis over 1 plus x. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.